In this lesson, we are going to review a few examples on quadratic equations, applications solved by using the quadratic formula and the discriminant to determine the number and type of solutions that a quadratic equation will have. The first example, it's an equation given in standard form, so the standard form of a quadratic. We're going to go ahead and solve this using the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So from this quadratic, my a is 1, b is 11, c is negative 12. I am going to substitute the values into the formula. You want to make sure you are careful. Can easily make a mistake while we're substituting, so it's good to take our time. So then, x equals negative 11 plus or minus the square root of 121. Negative 4 times 1 is negative 4 times negative 12 is positive 48. Over 2. So then we have negative 11 plus or minus 121 plus 48. Is it a perfect square? 121 plus 48, it's 169. Yes, that would be a perfect square. Over 2. So then we have negative 11 plus or minus square root of 169 is 13 over 2. So now this leaves me with the two answers, negative 11 plus 13 over 2 and negative 11 minus 13 over 2. So I have negative 11 plus 13, and that gives me negative 2 over 2, that's 1. Negative 11 plus 13 minus 13 gives me negative 24. Oops, running out of space. Let's see. Let's rewrite this a little bit smaller, right? Want to make sure everything fits. Negative 11 minus 13 over 2, negative 24 over 2, negative 12. So my two answers for this quadratic is 1 and negative 12. And I solved it using the quadratic formula. In this one, we also have it in standard form, and we're going to use the quadratic formula again. Let's pick a color. We barely use pink. Let's use hot pink. That's a nice color. Again, I'm going to rewrite my formula, because the more I rewrite it, the more I'll memorize it. I always do that. Every time I teach this, I rewrite it as many times as I need to for the lesson, hoping that the students understand it. So A is 5. B is negative 14, C is negative 3. Go ahead and substitute. I think it's too much pink. Already got tired of it. Can you believe that? Okay, so x equals B is negative 14 plus or minus the square root of negative 14 square minus 4. A is 5, C is negative 3. Substitute that. 5. Perfect. Oh, my neck is getting tired. We can do this. Okay, let's simplify the signs. Negative times negative is a positive. Perfect. And 14 times 14, so 14 squared is 196. And then we have negative 4 times 5 times negative 3 gives me 60, positive 60. 2 times 5 is 10. Okay, I feel like I keep writing really big and then I run out of space. Don't you think? I think so too. So 196 plus 60 is 256. Let's try that again. 196 plus 50, 246. Okay, I'm definitely not doing this right. I want you to make sure you are checking my arithmetic. So that gives me 256. 256 over 10. Is 256 a perfect square? It is. 16. Wow, check that out. 16 over 10. So now we're going to break this into our two answers. 14 plus 16 over 10 is going to equal something. 14 minus 16 over 10 is going to equal something. So what is that? I want to make sure you are checking my work. 30 over 10, which I can do that part, is 3. And then 14 minus 16 is negative 2 over 10. We can only simplify that into negative 1/5. So there you go. We get two answers again. Perfecto. Two answers for a quadratic equation. So again, we use our quadratic formula. We substitute our values here. We took our time. Make sure you let me write that. Take your time. You want to take your time. Don't make mistakes. Double check your work. Okay? Two answers. Next example. Oh, you see I had extra space here that I didn't use. Well, it's okay. Let's just say we are happy. Okay, one more example. So in this application, we're going to use a quadratic formula to solve it. But first we have to set it up so we can have an equation. So let's go ahead and read it. It says the length of one leg of a right triangle. Good information, perfect information. Right triangle is 1 centimeter, more than twice the length of the other leg. Okay, this is an extremely important sentence right here. This tells us a lot of information. Okay, the hypotenuse measures 6 centimeters. 6 centimeters. Find the length of the legs. Round to 1 decimal. Okay, so we have the picture here of a right triangle, and we know that the height will be B, and the base B, A, B, C. Height is A, base in B, and the hypotenuse is C. Okay, so the formula that we always use for right triangles is the Pythagorean theorem. So I have that, and this is what's going to help me set up the equation. Okay, this is what's going to help me set it up. Now what is going to help me solve it? What is going to help me set it up? Okay, so then I need to take the information that I got from the problem. So it says that the hypotenuse is 6 centimeters. I have that right here. Perfect. Then it tells me that one leg is 1 centimeter more than twice the other. So the one that I don't know is A. And if I don't know A, that means that the base is 2 times plus 1, whatever A is. So this is why I have this right here. Okay. So you see 1 centimeter more, so that's a plus 1. Twice, so that's times 2. So now I simply need to substitute what I know into the formula. So I know that 8 is x. I know that b is 2x plus 1. And I know that c is 6. So let's go ahead and do it in the next page. So the Pythagorean theorem is a squared plus b squared equals c squared. And I know that a is x. Okay. I know that b is 2x plus 1. And I know that c is 6. Now I simply need to simplify. Now we got to simplify. Okay. So x squared is just x squared. Good. Plus, this one is going to take a bit. 2x plus 1 times 2x plus 1. But it's okay. And 6 squared is 36. Here I'm going to FOIL. Foiling is always a handy. Oops, I was about to make a mistake there. That's why I have you guys to help me and catch my mistakes. So that's 4x squared. So then 2x times 1 is 2x. 2x times 1 is 2x. 1 times 1 is just 1. Equals 36. Now I need to combine like terms. Combine like terms. Okay, process of solving. So this is going to be, let's see, my like terms, x squared and 4x. That gives me 5x squared. 2x and 2x. That gives me 4x. And then just plus 1 equals 36. Okay, so I'm going to solve this using the quadratic from now, but I'm just going to complete it and put it in standard form in this page. Okay. So then that means I have 5x squared plus 4x minus 35 equals to 0. Okay, 0. That looks bad. Let's write it again, because it has to look a little bit nice. There. So now I'm going to read it, rewrite this in the next page. Oh, I don't have space. Okay, let's just move here, this page. Okay, so 5x squared plus 4x minus 35. 5, you know what? Let's do it a little bit more further. Here. 5x squared, I forgot. 5x squared, what is it? 5x squared plus 4x. 4x minus 35 equals to 0. I'm going to go ahead and write my quadratic formula here again. There, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Perfect. Okay, so now a is 5, b is 4, c is negative 35. Okay, we got it. Substitute. Negative 4 plus or minus 4 squared minus 4 times 5 times negative 35. Negative 35. Negative 4 plus or minus 4 squared is 16. That seems like a big number. Negative 4 times 5 times negative 35 gives you, wow, that's a big number, plus 700 over 10. I'm going to double check it. I don't trust it. Not because I don't trust my calculator, just because I don't trust my fingers typing it. So, plus or minus, what is that? 716 over 10. 716 does not sound like a perfect square to me, and it's not. It gives me a decimal. Now, it does make sense since we are dealing with an application to get a decimal. That sometimes do happen. Not always get nice numbers. And if you recall, the directions say round to 1 decimal place, right? So let's go ahead and rewrite this. We got one more space because it has a lot of decimals when you take the square root of that. And I do not want to round within the problem. That's not good to do. So for the sake of this video, I'm just going to rewrite all the decimals. A lot. Okay, so then we have two things. We're going to have negative 4 plus, let's call this decimal smiley face, because I do not want to rewrite it now, over 10. And then we're going to have negative 4 minus our beautiful smiley face over 10. So let's see, what does that give you? Make sure you double check it in the calculator. So that huge decimal, take away 4. That gives me 22, another big decimal, divided by 10. So that's 2.27. 5a and more things. But it says to round to 1 decimal place, so 2.3. Now, just by looking at this here, I have a negative, negative 4, and a negative big decimal. That's still going to stay negative, and it's going to be divided by a positive number. This is still going to be a negative. Let me write this in red so that makes even more sense. This is still going to be a negative answer. So Do you think we're going to use this answer? No, because it's a negative number and we're dealing with a distance, a measurement. Therefore, we need a positive answer. So I am not going to take the time to do that in the calculator. So my answer is 2.3 for one of the legs. The other leg, we need to go back and find it. So one leg is 2.3. Let's go back to our problem right here. The other leg, so this is 2.3, and the other leg is 2 times that plus 1. So 2 times 2.3 plus 1 is 5.6. Okay, and those are our measurements. So we did our application, we set it up using the Pythagorean theorem, and we go back, right here, we solved it using the quadratic formula and all of that. Now let's go back, we do have one more example right here. And this example wants us to find the discriminant in order to determine the number of solutions and the type of solutions a quadratic equation will have. So if we recall, the expression to use is b, I was going to write a negative there, is b squared minus 4ac. So if you look at your equation, it is not in standard form. Therefore, we got to put it in standard form to determine the discriminant. So we're going to make sure we do that. Okay. So then I'm going to substitute the A, which is 1, the B, which is 2, and the C, which is 1. So I have 2 squared minus 4 times 1 times 1. And that gives me 4 minus 4. That is 0. Oh, what does that mean if we go back in our rules for the discriminant? If the if the number you get from the discriminant equals to 0, that means you're going to have one rational solution. So for this one, we're going to have one rational solution. Okay, just one. If it equals to 0. Let's try the second one. So this one is not in the correct format. So let's rewrite it. Okay, equals to 0. So A is negative 5, B is 2, and C is 0. So then I have 2 squared minus 4 times A, which is negative 5, times C, which is 0. So this is just going to be 4, because negative 4 times negative 5 is positive 20, but times 0 is 0. So this is greater than 0. So which means we're going to have a real solution. And if it's a perfect square, that means we're going to have 2 rational solutions. So for this one, 2 rational solutions. So for the discriminant, you want to make sure you know your rules. You have to know the rules. This green color, it's beautiful, but I do not think it's good for the eye. So for the discriminant, you have to know your rules. Okay, because if not, it doesn't work. You got to know how to work the rules out. Okay, so in this video, for this lesson, we use a quadratic formula to solve some quadratic equations. We use applications that involve solving using the quadratic formula. And we use the discriminant to help us identify the number and the types of solutions a quadratic equation has.